Howdy! Welcome to another solution to Ted Shifrin's Multivariable Mathematics. Today we're going to look at problem 1.3.5. That's chapter 1, section 3, problem 5. Let's take a look. Given vectors v1 through vk in Rn, prove that v equaling the span of those vectors is the smallest subspace containing them all. So we already know it's a subspace. We're not going to prove that much. And what does he mean when he says it's the smallest? What does that exactly mean? So to clarify, that is, prove that if W is a subspace of Rn, it's just some subspace, and we also know that that subspace W contains each one of these vectors v1 through vk individually. So it contains v1, it contains v2, and all of those by themselves, right? Then we'll know that the span of those vectors v is a subspace of W. A subset, but we already know it's a subspace, so subspace of W. Okay? So how are we going to show that? All right, this one is going to be a nice little one-liner. So we know that if v1 through vk belong to W, what do we know if we know that that's true? So we're given that v1 through vk belong to W, but we know that W is a subspace, so it's closed with respect to addition and scalar multiplication. So any combination like this, any linear combination, is also an element of W. But look, when I say any linear combination, remember, what's the span of these? It's the set of all linear combinations, which is like saying any arbitrary element, this right here belongs to V, so any arbitrary element of V also belongs to W. Thus, V is a subspace of W. And that's the proof. That's all there is. All right, I hope you enjoyed, folks. I'll see you next time.